Is the screen displaying what I'm seeing here now?
Yes, it's right now.
Okay. Greetings, everybody. Hey, I appreciate you inviting me here. This is a wonderful part of the world, and it's a real honor for me to meet so many people, great people from this region. I'm going to talk to you today about a couple different subjects, so please don't let it catch you off guard when I switch from one to the next. The first of these is when an unstoppable force hits an immovable object, you know something bad's going to happen. This starts out with USS San Francisco, a submarine that is being under production. You can see pictures of the scaffolding built around it and get an idea of the size of this sub. So this is 6,900 tons of metal. It sailed from Opry Harbor in Guam on January 8th, 2005. They're about 360 miles southeast of Guam at about 500-foot depth elevation, 80% throttle. The spirits of the men on this ship were high. They were kind of excited going out to port. There was 136 people on this ship, and they'd been in port for 4 months, upgrading the systems and putting everything in perfect shape. And so it's lunchtime. Everybody's heading towards the mess hall. The commander is Captain Mooney. He heads towards the wardroom. It's where all the officers go and meet and have lunch together. And I understand that the chairs in the lunch hall are attached to the floor so they won't move around as the ship rocks and rolls. And they're bringing food in. The captain goes in and sits down at his chair, and all of a sudden he hears a noise, and it turns into a terrible crash. And he doesn't quite understand what's going on. One of the people delivering the food to the area goes flying across the table, hits the captain in the chest so hard he rolls up over top of his head, nearly breaks his neck off. There's sailors flying through the air all over the place, sprawled all over. Some of them are unconscious, a bunch of them are dazed. Captain Mooney yells out, "What just happened?" And he realizes they got to surface. One of the senior crewmen in the control room hits some chicken switches. It's intended to cause the ship to rise up. It released high pressure air into some ballast, but nothing happens. The ship's sitting still. 10 seconds goes by, 20 seconds, 30 seconds. The captain later commented that he thought it felt like a lifetime, and for a while he thought they were going to die. And then the senior captain hit some other chicken switches and caused the rear ballast to release high pressure air into the back of the ship, and slowly the back of the ship starts rising. And it's going up to the surface of the water, but it's vertical. The front of the ship's down, the back of the ship's up, so you can imagine all the sailors inside are laying on the walls of the ship. And as they finally get up, they make it back to Opry Harbor. They're studying what went on. They realized as this is going on that they crashed into the side of a mountain at 38 miles an hour, and they later discovered that they had maps of this mountain, and had they stopped and studied these well enough, they'd have been able to avoid this disaster. But you can kind of get an idea of how bad the wreckage was on this ship. So one crew member died. There was 98 injured. The captain and 3 of his officers were relieved of their positions. I talked to one of the individuals who was involved in the forensic investigation of this disaster after the fact, and he told us that the welds on the front of this ship were all good, all but a half of an inch, 12 millimeters of weld were made improperly, and all of the tears that you can see on the front of this submarine propagated from that half inch. And the whole purpose for me telling this story to you is, in one way or another, each and every one of you sitting in here is involved in welding, and you need to remember each day as you do your jobs the importance of what we do. People's lives can depend on it. The entire infrastructure of cities depends on it. So take this job seriously as you do it, and think about the kind of disasters that can take place when welding isn't done properly. I'm switching subjects now. When I first started as a welder, I was working in a powerhouse, and I remember walking past an older guy who was welding, and he was stick welding. He was so good at it, it just impressed me. I just loved watching him do it, and I would stand behind him and admire his work. And I remember one day asking him why he didn't go work in a fab shop. He wouldn't be subject to weather and different kinds of circumstances that you find out on a job site. And he said he didn't want to be in a fab shop. They make him use MIG guns there. And he didn't want to be part of anything having to do with a machine. And another thing that I remember in the earlier part of my career, so I'm living in Midwest United States, and they started importing cars from Japan. And I remember people saying, this is a fad. Those foreign cars aren't built very well. They're not going to last very long. Nobody's going to keep buying cars from Japan. Don't worry about it. They'll switch back over to Detroit. Well, everybody knows how all that worked out. More and more cars come into the United States. Michigan, the city of Detroit, started to decline. The whole state of Michigan declined. It changed our economy around. And I remember somebody telling me, well, I'm glad I work in the construction industry, because you might be able to import a car into the country, but you'll never be able to import a construction project. I wish you'd keep that in mind as I go through this presentation, because it's going to become more and more aware to you why I talk to you about this. So I'm in New Zealand now. This is overlooking Auckland. It's a beautiful country, just like the area around Lima here, and an inlet of water. But the reason I'm talking about this, we were adding on to a refinery. Those are about 36-inch diameter pipe, inch and a quarter wall. This is a 1 1/4 chrome moly. And they're joining these together, and there's a lot of 90s involved. And I remember looking at some of these, and to get the 90 square with the run of pipe, they had to have smaller gaps on one side and larger gaps on another. I went through this project and trained and got done, and I left there in about a week, and some time elapsed, and they started sending me emails saying that they were welding on the project, and they finished their first weld using mechanized equipment, and they were so proud of it because it passed X-ray. And this went on, and I kept getting more and more emails talking about the second weld, the third weld, and I personally, I was kind of proud of all of them, that they were doing so well on that project. And I got as I was saying, the use of this mechanized equipment helped these people to go from 30 hours per weld down to 8 to 9 hours. And the level of skill that an operator needs is considerably less than somebody who's trying to weld. And the quality of the weldment was such that they finished this entire project with thousands of welds and nearly no rejects. So I'm going to just allow this to go through its process here. And
procedures offering techniques such as short arc route, followed by flux core fill and cap passes to eliminate the time-consuming hot pass. AdaptArc's increased welding performance on this project produced consistent, defect-free, code-compliant welds in all processes, resulting in weld cycle time improvements from 30 hours per weld to 8 to 9 hours. That's about a third of the time necessary compared to conventional methods. Through the close support and successful partnering with Tri-Tool, Column Engineering consistently delivers superior fabrication solutions for their customers' most demanding requirements.
amazing what you can do, and you bend the microphone down to the speaker well close enough. Maybe you heard some of that, but anyway. I got invited back to New Zealand after some time elapsed, and I remember coming into this plant, and they had a pipe fit up, and as I was talking to you earlier about a 90 fitting onto a straight run of pipe, they had a gap on one side of the pipe of about 6 millimeters. On the other side of the pipe, it was maybe 10 millimeters, and I remember looking at it and thinking, what are they going to do with it? How are you going to bridge a 10 millimeter gap? Not that you're okay, some of the metallurgists in here would be thinking, who would want to bridge a 10 millimeter gap, but or welding engineers, but that was their plan because the 90 didn't fit up properly with a straight run of the pipe. And I remember watching this individual who's running this machine, and when I had first gotten there, they presented him as somebody who wasn't really a welder, wasn't very good, couldn't do high quality work. He was mostly for tacking, but I had trained him on how to run this machine, and he'd gone from what they called just a tacker to somebody who was extremely proficient at doing this. And I watched as he started welding, and he went from the top to the bottom, and he adjusted the parameters so that he could overcome the width differences, and he filled that root in. And I recall him getting done with the root pass and standing up and look at me, and he was so proud of the work that he was done. He was just smiling ear to ear, beaming that he'd learned so much about running this machine. But as I go into the next slide, I want you to realize you're looking at a root pass that's actually going in using a mechanized piece of equipment. And so just below the arc there, you can see an open root. That's about maybe 8 inches width, 8 millimeters width opening, and he was bridging that gap. I was watching from the opposite side of the pipe, and so here's the inside of the pipe, a picture of the inside of the root pass. You can see the smooth contour and the consistency. This is for anybody who's ever been involved in putting root passes in manually. You know it's not very easy to do this. I personally have done thousands of them. A person can get maybe 8 or 10 inches of travel before you got to stop and reposition your body, reposition the torch, and every time you start and stop, there's inconsistencies in the appearance of the bead. when a machine does this, you can go from the top to the bottom and never stop, and so there are no inconsistencies. Another picture of the root pass. And then after we got done with the root, we'd switch to flux core, and we could carry substantial amounts of metal, filling these joints up with flux core root, and because it's a machine, it puts it in so consistently. There's very few ripples and bumps and nothing for the slag to adhere to, and it just peels itself off just naturally, like you're seeing there. So that's a picture of it getting close to being full. Here's a different joint that we worked on. If you look closely, you can see a long ceramic TIG cup sticking down into that bevel. That is about 4.5-inch thick chrome moly. This is about 100 millimeters long, a cup sticking down into that. So we would put first few passes in with TIG, tungsten, or GTAW, and then switch to a flux core process, but you get an idea of how big some of these joints are. So we're moving away from the project we worked on in New Zealand now, and we're going to Southern California. There's an individual, some of you might know, Warren Buffett. He started and owns, or CEO of Berkshire Hathaway, an investment firm. And this is in Calpatria, California, by the Salton Sea. It's northeast of San Diego, kind of east of Los Angeles. So these are geothermal plants. And if you look carefully, off in the distance, there's 7 different plants that are producing steam here. One of the most important parts of what I like to draw out here is, so Warren Buffett's an investment guy. He thinks a lot about money, and he's got all these plants running, producing energy. He produces about 70 to 80% of the power that's needed for all of Los Angeles and San Diego from these geothermal plants. They're not consuming any energy to run anything. This is all 450 to 600 degrees Fahrenheit steam squirting out of the ground, but there's a lot of salts in it, so they got to filter the salts out before it goes into the steam generators. Well, he built all these plants out of carbon steel. Well, most of you people understand 450 to 600 degree Fahrenheit with a bunch of salt going through it, high pressure, it's going to corrode through carbon steel, and it was doing so in about a year. So they had to keep shutting these plants off, replacing all the piping systems, and they come to somebody like you who knows a little bit about metal and says, hey, is there something better than carbon steel we can use? Yeah, there is. So they decided to change all this to super duplex stainless steel 2507 alloy 59 filler wire, and so they came to our company, and we were doing a demonstration for them how you can. They asked us to weld it with TIG. It was taking 13 passes, 11 hours, to weld a 24-inch diameter, about a half-inch thick wall with TIG, because TIG's a slow process. I want to draw out to you here the availability of different technologies that exist, but people fail to use them because they don't know very much about them. They're scared of trying anything new, and they resort to what they've always done. So one of my colleagues is doing this demonstration with TIG on one side of the wall. I'm on the other side of the wall getting ready for AWS show, a FabTech show. It's going to happen, and I'm welding some carbon steel out, stainless steel. It was like some 316 or something like that. but I'm using pulse spray. And so, and my pipe was 24-inch diameter. Theirs is 24. Theirs is super duplex. Mine's 360. They both look kind of silver. They're shiny. Who can tell the difference, you know? And so, but their weld is taking 13 passes, 11 hours. I'm doing mine in 2.5 hours. I get done with a pipe, take it down, put another one up. I'm doing the second one, practicing, dialing in my parameters, getting ready for the show. This inspector guy who comes from Calpatria, he keeps walking around this wall looking at me doing it in 2.5 hours. That guy doing it in 11 hours. He's asked me if can you do that on my pipe? I don't even know who he is. I'm not involved in that project. He's whispering in the back of my ear while I'm welding. I don't want no one talking to me when I'm welding. I'm totally focused on that weld pool. He's bothering me. He keeps asking me, can you do this on my pipe? I'm thinking, would you just get away from me and leave me alone? But pretty soon, out of frustration, I says, of course I can. I don't even know who I'm talking to. He gets done, goes away. A couple days goes by. I get a conference call. There's 11 people on the phone. They say, bring all that stuff down to Calpatria. And who is this? I don't even know who I'm talking to. It's that guy who was in your shop. Well, I never welded on super duplex with pulse spray in my life, so I had no idea what it was. You know, it's way runny like Inconel or Monel or something like that. So it was a whole project that we had to start, but we were successful. We went down to Calpatria, welded a bunch of these joints out. Out of all the joints that we did, there were 0 rejects. We reduced their weld time down to about 2.5 hours per joint. To those of you who don't know, if there is anybody in here, I know there's a lot of educated people here, but when you... This is a picture of pulse spray, super duplex being deposited. So pulse spray, you might know, is 1 drop per pulse. We got about 450 pulses taking place per second going on there. 1 droplet of metal is going from the wire into the pool. 450 droplets per second. This is a high-speed photography of that same puddle. We've enhanced the picture a little bit to reduce all the light so you can kind of get an idea of how that puddle looks while this weld's being made. So when you get done with the weld, what you're looking at here is on the one side, there's a root pass and a hot pass deposited. On the other side, there's 1 pass of pulse spray. We nearly went from a hot pass to a flush in 1 pass of pulse spray. A second pass and it was close to being flush. We had to do a couple areas and then we could put a cap pass on it, but it significantly reduced their weld time, and it kind of draws out to you the advantages of people picking the correct processes instead of resorting to what they know best. So here's a joint that's getting ready to go out to the field, and we, as I said, we finished that project with no rejects, and they're still working down there today installing super duplex, because this is a massive area with a lot of piping, and all of it was carbon steel. And but a lot of you would know the advantages of 2507 in that kind of an atmosphere. So I'm switching subjects again. We're leaving Southern California. We're going to Thailand. This is a Unitai shipyards, and it is a pretty poor area. I couldn't take too many pictures inside of this shipyard. They were kind of protective of anything that's going on in there. But you can see the shipyards in the background give you an idea of how massive this place is. And so I'm there for a week doing some training on some of their folks, and they're figuring out how this equipment works, and they're doing fairly well, and they're progressing through the training process, and we're making some fairly nice looking welds. And this, understand that they've never seen a machine in their life. This is about the third day that I'm there, and they're making quality welds with this equipment that quickly. Of course, they're welders, and they know a good weld when they see one, but they still have to make the transition from how do I move an electrode or a MIG gun back and forth to pushing buttons to make all this happen and increase productivity. And they're kind of proud of their work and showing off a little bit about we like what we're seeing here. And there's a picture, the guy in the middle's, the good-looking guy in the middle's me. But anyway, so we're getting, and I got kind of bored as things were going on, and I was walking around looking out the end of the plant here, and I walked out and I looked to my left and I sees this big structure, and I was studying a little bit, as tall as it is, and I noticed that it's not attached to the ground. It's up on dunnage, big railroad ties. And I'm thinking, why are they building something that big and not hooking it down to concrete? And I started getting nosy, and I asked, and they takes me walking around in there, and I'm looking at this piping and all this preheat equipment, and I realized I'm looking at 9 chrome pipe. This is 9% chrome moly piping, and I'm trying to figure out what I'm looking at, and they tell me, well, this is a combined cycle powerhouse. I said, this is a shipyards. What are you doing building a combined cycle powerhouse in a shipyards? And they said, well, we build anything we can get contracts for here. And I said, what are you going to do with it? We're going to put it on a ship, and we're going to send it to the United States. You guys get to make about 100 welds, and you can turn it on. And right then, I remembered that guy in the earlier part of my career saying, I'm glad we work in the construction industry, because you might be able to import a car. You'll never be able to import a construction project. And I thought, that's a lie. And why am I telling you about all this? The equipment we sell, most of it, I market, train, and goes into the Philippines, Thailand, maybe China, Saudi Arabia, sometimes Australia, sometimes New Zealand. I find it so paradoxical that my own country, where we build the equipment, buys little of it. And I just heard them talking earlier today about the productivity in Peru. And this is the same situation in both of these countries. The use of this mechanized equipment will enhance your productivity significantly, and the skill levels that your workers need isn't quite as great. So you need to embrace this new type of technology and teach your workers how to use it, because it's very effective and it works very well. And so in a spare time, I was walking around in this area and looking at some of the scenery that I see, and they take me to a restaurant. And it was an open-air restaurant. When I walked through the door, they hand me a bamboo pole. And it's about 4 foot long. It's kind of dirty. And I'm thinking, what am I supposed to do with this pole? But the girl, she speaks, Thai, and I speak. I can't ask her what it's for. I just go follow these people I'm with to the table. Ask the guy, what's this bamboo stick for? He says, you'll figure it out. So I'm sitting there looking around, and I see this monkey come through the window. And he starts crawling across the table where I'm sitting. He's getting close to me. And right then I figured out I know what the bamboo stick's for. So I picks it up. He crawls underneath the table. I'm scared he's going to bite my ankle, but I watch him. He goes down underneath the table, and there's a guy and a girl. They're young. They're flirting with each other, and the guy's so enamored looking at this girl that he's not paying attention. Right then, I see this little monkey's hand come up over the side of the table, reach down into his bowl, grab a whole bunch of food, and go out the window he goes. And so you're probably thinking, what the heck has this got to do with welding? Nothing. I just thought it was real funny when I was there, and I use it to kind of help people stay awake when I'm giving a presentation. So we're leaving Thailand now, and we're going to a nuclear powerhouse. 16-inch diameter feed water piping. We got a problem here because this is a nuclear powerhouse and they got a leak, and you don't like hearing those two things used together in the same sentence, a nuclear powerhouse with a leak. So this big valve that you can see in the picture, it's about 7 foot tall. The water's leaking through that. We got to cut that joint out and make another weld. The water's leaking through the valve. We can't shut it off, and we got to put a root pass. You can't weld underneath running water, so we're trying to heat that valve up so hot that it vaporizes, and we succeeded in doing so. It turned it into steam before it got into the air of the root pass. This individual here is somebody that I got to know real well in the United States, one of the best welders I ever met in my life. To give you an idea of the kind of income that people can make in the construction industry, this individual, I would go to his house at nighttime, and we'd sit around having a hot dog or something and drinking bourbon. His daddy made moonshine. And it was, matter of fact, it was pretty good stuff, but it was very strong. But we'd sit around talking and relaxing, and at about 7 o'clock at night, he would pull a jack stand out and a tripod, and he'd pull a pipe out and he'd start welding. I would say to him, his name's Hatter, "What are you doing? You're one of the best welders I've ever met in my life." And he says, "The only way I'm going to stay that way is practicing." At nighttime, he'd be practicing welding. But you know what? He was making $225,000 a year as a welder. You need to tell people in your country the amount of money that can be made as a welder if you're good. And if you know how to do these kinds of jobs, particularly if you're involved in mechanized welding, you can make substantial amount of money working as a welder. I know another individual in Northern California works for a public utility. A young guy, 27 years old, not married, saving to buy a house. He's making $225,000 a year. And the bank tells him he can't put any more money in this bank. You've exceeded FDIC insurance. So I'm trying to point out to you, not only are there good careers in the welding industry, but they can be very lucrative. This is a cover pass that guy put on that valve, that same valve we were looking at earlier. You can see the transition from the pipe to the thick wall body of the valve. There's no notches there. It's very good quality work. So, another picture there. So I'm switching subjects again. You might have maybe thought that I've talked about a bunch of round stuff that's involved with mechanized welding, but you can do mechanized welding with pipe or vessels and that kind of thing, but you can't do it with structural. So these two, that's a laser that's scanning a table that's got a whole bunch of components on it, so it can figure out what it's got to do and what it's going to install. That picture you just saw was it figuring out where the beam is. Now it's inserting a component down in the beam, and that same device is going over there and welding it. If you look close, you can see lasers on the end of that MIG gun that's spotting where the transition angle is and figuring out where it needs to be putting these fillet welds. And it's turning the beam over so they can put gussets on the back side of that beam. This equipment doesn't quite move as fast as it looks like it's going on here. I speeded this up a little bit. But you know, when I was working in the nuclear industry, we always would go in and put these machines in on, this is I mean to say, this is a plant that's been running, so there's radioactivity in the primary reactor, and we didn't want to stay in there and weld, so we had video remote control systems, and I would sit out in a control room and make the welds, and I knew with a machine this big and fancy that there's somewhere around here that they've got control rooms that are being used, and I went to meet the individual that was running this machine. That's him, and I remember talking to him briefly, and he talked to me about how he started out as a welder, but he advanced his skills, and he's gotten to the point where he can run this kind of equipment that well, and he was real proud of the progress he had made in his life, and sitting in his own control room running this equipment. To give you an idea, though, to wrap this up, according to the American Welding Society data, among the roughly 450,000 U.S. welders, the average age is in the mid-50s, and the fewer than 20% of them are under 35 years old. I about imagine this is kind of a statistic that is similar throughout the world. According to the American Welding Society, they estimate there's a shortage of almost 400,000 welding operators in the industry by 2024. We need to educate more of these people and bring them into our industry so it can flourish and grow, and so organizations like IIW can have more people to be involved with them, and we can standardize things around the world. Hey, I really appreciate you guys giving me some time to talk to you. It's a great honor to be here in your country, and thank you so much for listening. And
we want to thank you, Mr. Fluke. You can pass here to the head table, please. Bueno, ahora es tiempo para pasar a las sesiones paralelas. Solo quiero comentarles que van a iniciarse sesiones tanto aquí en el Polideportivo como en el Auditorio de Ciencias Sociales. Para llegar al Auditorio de Ciencias Sociales, ustedes pueden seguir la avenida principal por donde vinieron, y ahí van a aparecer varios carteles que les van a indicar dónde va a ser. También comentarles que vamos a hacer un pequeño break de 15 minutos, un pequeño coffee break afuera, pero también comentarles que como empezamos un poco tarde, vamos a mover 15 minutos, ¿no? La programación que está estipulada, ¿no? Bueno, muchas gracias, nos vemos dentro de 15 minutos. Y también me estaba olvidando comentarles a las personas que siguen en las sesiones paralelas, les invito a pasar aquí adelante a que me puedan pasar también sus diapositivas y a explicarle algunas consideraciones sobre sus exposiciones. Muchas gracias.